Hey everyone, let's take a look at number 6 in section 6.2. We're going to let f of x be the square root of x function. We're going to find a value c in this interval. And again, your numbers might be slightly different, such that what the f of this c is equal to the average of f, or the average value of f over the same interval. And then give your answers to 3 decimal places. Okay, so remember in this section we introduced the average value of the function. Here it is. You need to know this. This won't be given to you, but it's basically just like we find an average for a finite set of values. We add up all the values up and we divide by the total number. Well, here we have an infinite number of values, but we're integrating, right? Excuse me, from A to B. So this would be on the interval from A to B. And we're just basically adding up, in a sense, all those values and then dividing by the length of the interval. This is 1 over B minus A is just the length of the interval. So that's all we're doing to find the average value. Now, in this particular problem, we're finding the value of the function f of c, right? Or finding the value of c, rather, in this interval such that the value of the function is equal to the average value. And this is the mean value theorem, which states that for a continuous function, that the um, uh, average value the function will take on its average value at least 1 point in the interval. Um, and we talk about that in class. And so I would refer you to the lecture video over this section, that you carefully watch that and understand that relationship, and really an intuitive graphical understanding of what the average value represents. Okay, so let's get into the nuts and bolts of it. First of all, we're going to find the average value for this function. So on the interval from 6 to 18, so a is 6, b is 18. So b minus a is 18 minus 6, integral from a to b. And the square root of x I'll write as x to the 1/2 power. Of course, this becomes 1/12. The antiderivative of x to the 1/2 is 2/3 x to the 3/2 by the power rule. And then simplifying here, 1/12 times 2/3 is what? 2 cancels with the 12. 6 there, 6 times 3, we get 1/18. And then I evaluated the upper limit of 18 and lower limit of 6. Now I'm going to use my calculator to do this computation. And let me just do that real quick. So the way I would do this is just 18 to the 3/2 power, which is the same as 1.5. Let me actually put that in parentheses, because I'm going to, multiplying by 1/18 is the same as dividing by 18. So that's what I'm going to do. So 6 to the 1/3 power, whoops, and divided by 18. So this is the expression, and we get that value, which I rounded off here. But I would not round off to the very end here. They want you to round to 3 decimal places. So, I mean, you could round this to 3 decimal places, but if you use that value on the next step, you might be off in the last decimal place. So keep this in your calculator. And now, this is the average value approximately for the function, okay, over that interval. And so essentially, again, in a graphical interpretation of the average value, if we graph this constant function, about 3.426, from 6 to 18, the area under that constant function, which would just be a rectangle, right? The area of that would be equal to the integral from a to b of the function f of x, because I can just multiply both sides of this by b minus a, and I can see that relationship. So when is f of c equal to the average value? Well, f of c would be the square root of c. And when is the square root of c equal to this? Squaring both sides when c is the square of that value. And I would just use the answer key and square it. Or you can just hit, I think, the squaring button. It'll automatically square this value, right? Remember, answer restores the value of your previous result. And there it is. And so rounding to 3 decimal places, since this is a 4, we keep that at 8. And there's your answer. Okay. Hope this is helpful.